Flack math! Give me some math and I'll give you some flack. Flack math!
All right, so lesson 41, we're going to add like terms in rational expressions, okay? So we're going to add, we know how to add like terms, we know how to recognize like terms. But in rational expressions, remember that's just a fancy algebra word for fractions, okay? Something over something. So let's go into that. I'm trying to avoid any kind of window there. I don't know if there's a window there, but okay. So if we have something like this, bx over x cubed y to the -2 minus 3by squared x to the -2 plus 4y squared over bx squared. That looks like a mess. And at first glance, it doesn't look like there's any like terms, right? It looks messy. It doesn't look like there's any like terms. But let's put these all in the same format. Remember, there's different formats with positive and negative exponents. So if I decide, okay, I don't like fractions and I'm going to bring everything upstairs, then I can do that. So remember, when you bring something upstairs, you just change the sign of the exponent. This is a really easy concept. It's just hard to remember if you're struggling to remember. So this x to the +3 downstairs becomes an x to the -3 upstairs. This y to the -2 becomes a y to the +2 upstairs. Okay, that one's already, everything's upstairs, so I'm going to ignore that. I'm going to bring this upstairs. So this is a b. So what's the exponent for b? I don't see an exponent for b. Can you hold up a finger? What's the exponent of, oh, I guess I just gave you the answer. You hold up one finger. The exponent is just 1, right? So upstairs, it is b to the -1. And then this x squared becomes x to the -2. All right, so now we can ignore those denominators because everything is upstairs now. But now we can just simplify what we can here. So there's an x to the 1 and x to the -3. Those can be simplified to x to the -2, because remember, when you multiply variable expressions, you just add their exponents. Okay, and y squared, and then this one is still the same, b. I'm going to write it in alphabetical order because you can see that there's some likeness there. And this is the only one that doesn't work, unfortunately. B to the -1, x to the -2, y squared. So this was almost a like term, but not quite, right? That little -1 made it not like these others. But you can combine these together. There's no number in front of that, so that's a, or 1b x to the -2 y squared. So 1 minus 3 is -2 b x to the -2 y squared, plus this guy didn't get to combine with anything, so leave it alone. Okay, so those are rational expressions. Well, first of all, rational expressions you can turn into normal expressions. You don't have to deal with fractions unless you want to. The other way to do this problem is to just make all the exponents positive. If I did that, this is what it would look like. And I'm going to kind of skip to that right now. If I just made every exponent positive, then I would have, let's see, the only negative exponents is that y to the -2 on the bottom. So if I bring that up, it's, and then I subtract the exponents, 1 minus 3 there. So you end up with by squared on top, then x squared on the bottom. Okay, and then minus 3by squared, and that x to the -2 has to go to the bottom to be a positive exponent. And then I've got this guy, which is just the same, 4y squared over bx squared. So you can see that these two have the same denominator, right? So I could combine those to, okay, so that's 1 of those minus 3 of those, so negative 2 by squareds over x squared plus 4y squared over bx squared. So these, you can also combine it like that, but those are, we had to like just combine ones with common denominators. I'm not against fractions, but fractions just complicate things. All right. They fraction things up. Okay. So if you can avoid fractions and dealing with fractions, it's probably safer to not. If you have a choice, then don't overcomplicate it unless you have to. Okay. So let's try an example. Let's see if you guys can try this example. So basically the first step to these is just clean it up. And then actually we kind of did the first example. So let's do example 2. Your first step is to clean up these separate terms first and then see if you can combine them together. Okay, so here's example 2. There's just 2 terms, a to the negative 3b all over b to the negative 3 plus 2b to the 4th all over a cubed. Okay, so let's clean it up first. So you can either make all the exponents positive and simplify. I wouldn't recommend that because you'll end up with fractions. Or you can bring all the guys living in the basement, bring them upstairs and change the sign of their exponent and then clean up those separate terms. So take a few seconds and just clean them up and then see if you end up with like terms. Remember, like terms have to have the same variables with the exact same exponents.
You do stuff in your head? My son did too.
Zan likes to do things in his head. Sometimes it pays off, sometimes it doesn't. There's no music today?
They're disgusting.
Oh. All right, I'm jumping in. Okay, so maybe some of you have already done this, but the first step is really easy. You're just bringing everything in the denominator up to the numerator. You can do that all day long. So you don't ever have to deal with fractions in your whole life if you don't want to, because all you have to do is bring the denominator up to the numerator. So for example, if I didn't want to deal with 3/4, I could just bring it up to the numerator and say, this is just 3 times 4 to the negative 1. So if I had 3/4 of my pecan pie yesterday, I didn't. That would be, I would have a problem. I wouldn't have to use a fraction. I would say I had 3 times 4 to the negative 1 parts of my pie yesterday. And I could say that. I could eliminate fractions from my life completely. But that's a little much. Okay, so if I bring b to the negative 3rd upstairs, what does it become? B to the positive 3rd. If I bring a to the positive 3rd upstairs, what does it become? A to the negative 3rd. Okay, so now I can just ignore those denominators. So here's what we need to clean up. Well, how do you multiply exponential expressions with the same base? You just add their exponents. Okay, so this one is a to the negative 3rd, b to the 1 plus 3 is 4. And then this is 2. Let's do a to the a first because it comes before b. A to the negative 3rd, and then b to the 4th. Hey, look, same variables with the same exact exponents. I can combine those. If I don't see a number there, put a 1 in front of it. You don't have to, but if it helps you, organize your stuff, then do it. So 1 of those plus 2 of those is 3 of those. Remember, you don't change the variables when you add. When you add like terms, you're not adding exponents and things. That's only when you multiply. So it's like 1 inch plus 2 inches is not 3 inches squared. It's just 3 inches. You don't touch the label. Don't touch the variables when you add or subtract. Okay? Anybody get that? It's okay. It's the first example. So if you didn't get it, that's okay. Don't sweat it. Let's try another example and see if we've learned anything here. Okay, now this next example, there's 3 terms, but 2 of them, you're going to end up with 2 like terms and 1 that doesn't belong. Okay, so your answer is going to be something plus something. You're going to end up with 2 terms because 2 of these 3 terms are going to be able to combine. Okay, so there's a little hint for you. Here's the third example. I'm going to scroll down a little bit. 7, a to the negative third, b squared all over c to the negative 1 minus b, or minus 5b squared over a cubed c to the negative 1 plus 3b squared all over a cubed c. So see if you can clean those up. Bring everything upstairs if you want. Clean up the terms and then see what combines. Okay, take about 30 seconds to try this by yourself. If you want to ask somebody next to you, you're welcome to. There's the music.
You just spoke too soon.
Sometimes it just takes a little music to be able to do a math problem.
There you go.
Okay, I'm going to start. So I'm going to move everything upstairs. So be really careful. There's so many times I see people move stuff upstairs and then they forget to change the sign of the exponent. So don't forget that. So this is a to the negative third, c to the positive 1. And this is a, I'm going to move this. My window's in the way, sorry. Oh, there we go. So a to the negative third, c to the, no exponent. So the exponent's 1, so that's negative 1. Okay, so those are done. So far, so good. All right, well, now I'm just gonna clean this up. This looks already cleaned up. There's no a's to multiply with a's and b's to multiply with b's and so on. All of these are really cleaned up, but they're just not in alphabetical order. So it might be difficult to see which ones are like terms. But if you can see it already, that these 2 are like terms and this one is not. Okay, because the c to the 1, c to the 1, c to the negative 1, they have to be the exact same exponent. So this does not belong to the others. So let's do the math. Don't forget, this is a subtraction sign here. So 7 minus 5 is 2. A to the negative thirds, b squared, c. Do I need that 1 exponent? No, I don't need that. And then plus, what didn't belong here was that guy, so I'm just going to write that alphabetical order, a to the negative third, b squared, c to the negative 1, and that's it. That's all you can do. It's frustrating because you want to just to combine them all together, but you're going to have to live with that small amount of dissatisfaction, so sorry. Okay, one more little concept, and then we are done with lesson 41, okay? So the other part of 41 is just two-step problems, which is different than two-step equations. All right, so let me tell you what two-step equations are first, just to remind you. Two-step problems. Two-step equations are equations that take two steps to solve. So for example, 3x plus 5 equals 17. Well, to solve this equation, you first have to get rid of the 5. That's one step. And then you have to get rid of the 3. Divided by 3, divided by 3, x equals 4, and you're done. These are two-step equations, okay? That's not what I'm talking about. I'm talking about two-step problems. So yes, there is an equation that you're going to solve, but that's only one step of the two steps. So let me just show you by example here. This is example 4. And I say if x plus 3 equals 7, then what is the value of, or what is x minus 8? Well, in the past, we've had problems like this. What is x minus 8 if x equals 4? And all you have to do is plug in 4 for x and you're done, right? Well, that's the same thing what you're doing here, but you are not given the x. You have to work for x. Okay, you have to work a little bit just to figure out what x is, and then you plug it into this x minus 8. Okay, not a big deal, just one extra step. So the two steps are solve for x in the equation that they give you. All right, so ignore the x minus 8 first in equation given, okay? And then step 2, plug in x. Plug it in, plug in value for x in the next expression. Okay, so that's what we're gonna do. Let's solve for x. Well, let's see. It's a really easy equation, right? So if it's x plus 3 equals 7, get rid of 3, x equals 4. All right, step 1 complete. Now, what some of you will do on the next test, you'll solve for x, and then you think you're done, right? Well, you're half done, and if you did that, you would get half credit on that problem, which is better than nothing. But don't forget to answer the question. The question is not solve for x. The question is, what is x minus 8? So now that you know what x is, it's 4, plug it into x minus 8. So that's what we're going to do now. So x minus 8 is just 4 minus 8, which is negative 4. That is your problem. Okay, so don't stop at just solving the equation. Plug it into the next value. Okay, one more example and we're done. So see if you guys can do this. I feel like this is a nice breath of fresh air after some rational expression combining like terms. That's kind of a little bit complicated, but do this nice, easy breezy problem here. If x minus 5 equals 7, what is the value of x plus 4? Some of you, most of you can just do this in your head, right? But follow the steps. You don't have to write it out on paper. If you want to try it in your head, go for it.
Good job.
Did I hear something?
Yeah.
Did I hear the right answer?
Say it louder so we can hear you. 16, they say.
16. That's right. Good job. So if I wanted to algebra this out, I'm going to nerd out a little bit. Plus 5, x equals 12. Awesome. Now I'm going to plug that 12 into right there. So 12 plus 4 equals 16. Done and done. Good night. Nice work, guys. All right. So that'll be on probably not this next test, but tests to come. So that's a nice, easy problem for you that you don't have to stress about. Okay, you good? All right, let's move on to lesson 42. Okay, so lesson 42 is a skill that you're going to learn that is you're going to use a lot in this class and algebra 2 and probably in a little bit in geometry as well. But lesson 42 is solving multivariable equations. So multi means more than one, but multivariable means more than one variable. So how can you get the variable by itself if there's more than one variable? Well, you still can. You just have to shove all the other variables to the other side. So what these problems feel like are like when your parents say to clean your room, you're not really putting anything away. You're just moving everything under your bed, or you're just putting it over on one side of the room. Doesn't feel like you're cleaning anything. So sometimes when you're desperate and you need a space to do something, you move all your junk over and then you could just do your thing there, but you're not really cleaning anything. That's what these problems feel like. So there may not be a lot of satisfaction that you get from these. It's more just rearranging your mess, okay? So let me show you by example here. Here's example 1. 6y minus x, more than one variable, plus z equals 4. Okay? And then it's they're not going to just give you this equation and say solve it. Okay? Because usually when they say solve it, you're solving for the one and only unknown or the one and only variable. But these have several variables. So what it's going to say is solve for one of these variables. So I'm going to say, let's just solve for z. Okay. So remember, the main goal is to get z by itself. Well, you can still follow the steps of equations. All right. But it's going to look a little different. You can still simplify both sides separately. So up on the board there, where you see the steps to the first step in black, number 1, is to simplify both sides separately. So look for parentheses and look for like terms. You don't have any of those on the side separately, right? So go on to step 2. Step 2 is if you have variables on both sides of the equation, then get rid of the smaller one. Well, you're only solving for y. So if you're going to follow these steps, you're going to have to tell yourself this. The only variable that you care about is the y, the one you're solving for. The rest you can treat like constants, okay? So there's no variables on both sides, but the next step, is it blue or green? Step 3, is it blue or green? I think it's green. Is it green? Step 3?
Sure.
Sometimes I think my computer's frozen, but then I realize that you guys just don't move. You're just like frozen. There's Token moved a little bit.
Somebody
Okay.
move.
I'm gonna assume step 3 is, oh wait, did I say y? I'm solving for z. Okay,
Z.
so but there's only one z on this side. So these guys I'm going to get rid of. So how do you get rid of these things? Well, you do the opposite operation. So if this is minus x, I'm going to add x to both sides. Okay, and then I'm left with 6y plus z equals What's 4 plus x?
4 plus x.
4 plus x. That's right. Okay. Now I'm solving for z. So how do you get rid of 6y? Well, it's being added. So get rid of 6y by subtracting. Z equals, what's 4 plus x minus 6y? Just copy and paste what I just said. 4 plus x minus 6y. And guess what? That's solving for z. Feels messy, right? It feels like you haven't accomplished anything, like you just wasted your life. Well, congratulations. You're just getting z by itself. So this is solving. So and the other Mr. Flack is going to tell you to do this a lot, where you have to isolate the right variable of what you're trying to solve for. Okay, so you need to know how to do these things, especially for other Mr. Flack, but you need to know how to do this for this class as well. Okay, so all we did was just move all the furniture over to this side. That's all we did. There's some shortcuts here too, guys. If you're moving a term over to the other side, then all you do is change the sign. It's kind of similar to negative exponents, but not really. When you move something over to the other side, this negative x becomes a positive x. This 6y becomes a negative 6y. So that's a nice little shortcut of moving things over to the other side. All right, well, what if I wanted to take this same equation here and solve for, I don't think I can do that, and solve for another variable. Let's say I wanted to solve for y. So if I had 6y minus x plus z equals 4, and I want to solve for y, well, let's get y by itself. First step, the same thing, simplify both sides, nothing to simplify, so we're done. If they have variables on both sides, well, there's only y's on this side, so I don't have to do that. And then get rid of the constants. Well, in this case, these are the constants. So I'm going to move both of these terms over here, and it becomes, so basically I've got 6y left on this side, and that negative x becomes a positive x on this side. Let's put the 4 first. Doesn't really matter in this case, but that negative x becomes a positive x, and that positive z becomes a negative z. So see how I did my shortcut. I bring terms over, and it becomes the opposite sign. So a negative x becomes a positive x, or minus x becomes a plus x over here. Plus z becomes a minus z over here. All right, now we're almost got y by itself, but we have one more thing to do. We have to divide everything by 6. Okay, so remember, you can't just divide one of these things by 6. You have to divide the whole thing by 6. So let's do that. You could get 4 divided by 6, which is 4 divided by 6. We can reduce that later. And then you get x over 6 minus z over 6. Okay, so 6 doesn't go into 4, but you can reduce that to 2/3 plus x over 6 minus z over 6. Okay, now if you get this far, then that's the most important part right there, is getting y by itself. Okay, but then there is a little bit of reducing we can do there. So I'm noticing that 4 and 6 are both even, so I can reduce that part of it. So you can write them as separate fractions first and then reduce, or you can reduce that first and then just rewrite what you can't reduce. Okay. All right. So see if you can get to this point, and we'll worry about cleaning up the answer in the end, but let's do another example and see if you can get to that point where you just get the variable by itself. Okay. Here's example 2. Example 2, 4x minus 2y plus 2 equals y minus 4. And I want to solve for y. So see if you can do that. So take about 60 seconds, 1 minute, and see if you can do a little, follow the steps on the board You don't have to do step 1 because there's no parentheses and no like terms on the same side, but this time you do have to do step 2. Okay? So follow step 2 and then finish it. Oh, look. I found some fabric softener in my sweatshirt.
Huh? Wondering what's itching your.
I thought I smelled like extra nice too. Why? I was like, I don't normally smell like that.
Especially in quarantine.
That's right. It's not pretty. Funny, the microphone, so whenever it notices sound coming from your end, it tries to pick up that sound. So the music just got really loud because trying to pick up that sound, so it automatically adjusts the input gain to like try to hear what's happening. All right, so I'm going to start. If you're still working, then you can keep working with me. But I'm going to do that second step, which is there's y's on both sides. So see the y's there? So if there's y's on both sides, I'm going to get rid of the smaller term. You don't have to get rid of the smaller term, but it does make things easier. So if I'm subtracting 2y over here, I'm going to add 2y to both sides. And so I'm left with 4x plus 2 on the left, right? Because I got rid of minus 2y equals y plus 2y is 3y minus 4. Now that same trick works. If I bring a negative 2y over here, it's a positive 3y, but there's already, or positive 2y, but there's already y here, so positive 2y and another y is 3y. So you could still do that same trick and just do that math in your head. 2y over here plus another y is 3y. Okay, so now I'm still solving for y. So now I'm looking at the right side to figure out what I have to get rid of. So step 3, get rid of constant on the now this time it's literally a constant. Minus 4, so to get rid of minus 4, you add 4. So then on the left side, I'm left with 4x plus 6. So far, so good, right? And then I've got just 3y over here, but I'm not quite don't have y by itself. So how do you get rid of that 3? Well, the 3 is being multiplied. So divide it. Divide everything by 3. So then I'm left with y equals that. Okay, raise your hand if you got this far, 4x plus 6 over 3. No hands? All right, did I go a little too fast? Yes. Okay. So all I'm doing is, and you got to think about it like this, I'm just rearranging the furniture type of thing. So I'm getting rid of stuff, trying to consolidate like stuff, and then get rid of everything else. So subtracting, so the first, you can still follow those same the steps of solving an equation, but that second step is if you have variables on both sides, remember your variable in this problem is just the y. So you're ignoring the x. So that's not a variable in this case. Okay, so the variables on both sides, yes, because you have y's on both sides because you're asked to solve for y. So to get rid of minus 2y, you add 2y. Cancels on that side and you're left with 3y on this side. All right, now you have to get the y by itself. So you have to get rid of this minus 4 first. To get rid of minus something, you add it. Whatever you do to one side, do to the other. All right, and then I'm left with 3y, almost have y by itself. To get rid of something being multiplied, you divide it. Whatever you do to one side, you do to the other. So now I'm left with this. Okay, so this is kind of like what we've always done, but we haven't done a lot of math. We just are just writing. It's kind of like you're writing down the steps, but without doing it. Okay. All right, so at this point, you can reduce a little bit. The 4 and 3 don't reduce, so I'm just going to leave that 4x over 3, or 4/3 x, plus, well, this reduces. 6 divided by 3, that's just 2. So all I'm doing is like the distributive property of division. Divide everything by 3. Well, 4x divided by 3 is just 4x divided by 3, plus 6 divided by 3. Well, 6 divided by 3 is just 2. Okay. All right. A couple more examples and then I'm done. So let's try. I'm going to write 2 examples on the board here. Let's see if you can do them. And you can work together if you want, as long as you have masks on. But let's see if you can do these 2 examples, and then we'll do the last one together. So I'm going to put these on the board and you can work for it. So here's example 3. And this is solve for P. And this is what it looks like. 4P plus 2A minus 5 equals 6A plus P. All right. And then here's example 4. As we're solving for X. And this is what this looks like. 5y plus x minus 2y minus 4 plus 3x equals 0. Okay, so these are 2 different problems. So try to do these 2. So take a few minutes, probably 5-ish, to see if you can do at least one of these, but see if you can do both, okay? So take 5 minutes. If you need help, ask somebody next to you, somebody who looks like they know what they're doing. Elkin's looking around. Does anybody look like they know what they're doing?
Wait. Yeah. We're farther
Can I
back.
see that you're not working? Or you do not know how to get started?
You can always come closer.
I'm just trying to think about it in my head.
Okay. Well, that's good.
Just like getting a glance, like problem at a glance. You know how they have like year at a glance? This is problem at a glance. Now it's like procrastinating with extra steps. There you go. I thought you were saying that.
You can get closer.
Oh, I thought you were security. I thought it was not.
Can you make it? Can you enlarge it?
Yeah, we
Uh-oh.
is it- uh-oh.
Oh, it just went away now. There it goes.
Is that a little better?
Yeah.
All right, you guys keep working. I'm going to slowly start example 3, but you guys keep working, and then we'll talk about 3 after I finish it, okay? Okay, so let's just go through what I did for 3. So this is where we started. Let's see if I can do this. Okay, so the first step is to simplify both sides. Remember, the only thing you're looking for are parentheses on the same side or like terms on the same side. We don't have like terms. We have a 4p. There's no other p variables. We have a 2a and we have a constant. There's no other a's on the left side and there's no other constants. There are some a's and p's on the other side, but remember, step 1 is just cleaning up each side separately first. So there's no like terms on the same side. So we're going to skip step 1 again. So step 2 is if you have variables on both sides. Now remember, the only variable that we're concerned about are the p's. And we do have p's on both sides. So it says eliminate the smaller one. Which one is smaller, 4p or 1p? Just 1p. So we're going to get rid of that p. So you can either do the shortcut and bring that positive p over there and it becomes negative p. Nobody wants negative p. So combine it with what's already over there, the 4p. So 4p and negative 1p is positive 3p, okay? So that's what's on the left. So you got rid of it on the right side, and then you just combined it with what was on the left side, and you're still left with 2a minus 5, and you're left with 6a on the right side, okay? So step 1 is done, or step 2 is done because you only have one variable you're solving for. So you got rid of the smaller variable term. Step 3 is get rid of the constants. Well, in this case, there's more than one constant. So you have to treat the other variables like a constant term. So if I were to modify step 3 on the board, I would say get rid of constant term on variable side or different variables. Get rid of those. And the way you do that is they're terms. So you add or subtract them. So if 2a is being added here, I'm going to get rid of it by subtracting it. Or do the shortcut. The 2a on the left side becomes a negative 2a on the right side. So what's 6a combined with negative 2a? 4a. Okay. All right. Now we still have this minus 5. That's still a constant we have to get rid of. How do you get rid of minus 5? Add 5. So what's 4a plus 5? 4a plus 5 because they're not like terms. So you just leave it 4a plus 5. Last step is get rid of that 3. That step 4 is get rid of coefficient on variable side. So to get rid of 3, which is being multiplied, you divide it. Whatever you do to one side, do to the other. Okay, so you're left with 4a plus 5 all divided by 3. Okay, so you have to divide each of these terms by 3. So 4a divided by 3 is just 4a divided by 3. 5 divided by 3 is just 5 divided by 3. That's it. Okay, and there's your answer. That's your, you can leave it like that because 4/3 doesn't reduce and 5/3 doesn't reduce. All right. So if you had time to do 4, then let's see if we get, so this time we are going to do step 1. Why are we doing step 1? I don't see any parentheses. But I do see like terms. There's some y's that we can cancel or combine, and then there's x's we can combine. Okay, so let's do the x's first, just because they come before y. So you have plus x and a plus 3x. Positive x and positive 3x is positive 4x. Let's do the y's. So 5y and negative 2y, or 5y minus 2y is 3y. Okay, and then you're just left with this minus 4. That's it. All right, so see how on the other problems we didn't have to do step 1. We didn't have any cleanup to do before we started solving and moving our furniture around. We had to clean up a couple things. We had to combine some terms. All right, well, let's go back to, now we're done with step 1. So step 2 is if you have variables on both sides, you got nothing on the right side, literally nothing on the right side. So you don't have to do step 2. And then step 3 is get rid of constant or other variables on the variable side. So we're solving for x. So that means we have to get rid of these two things. So if I use my shortcut and bring these over, then I'm left with 4x on this side, but the opposite of this on the other side. So 0, when you add anything to 0, it's just that itself. So a positive 3y becomes a negative 3y. A minus 4 becomes a plus 4. So see how that shortcut was nice. All I did was throw it over on the other side with the opposite sign. Okay, we're solving for x. So last step, divide by 4. So I get x equals negative 3y over 4 plus 4 over 4. Well, 3/4 doesn't reduce, but 4 over 4 sure does. So you can leave this 3/4 y plus 1. Boom.
Did you get it?
I actually solved for y.
Oh, did you solve for y?
Yeah.
Common mistake. And I usually give partial credit if you do that. If you do that on a test and you just read the thing wrong, this happens all the time. It's so funny. I mean, it's funny, but you should pat yourself on the back and say, good job for solving for y. So you should have gotten, let's see, if you solve for y, you would have gotten y equals 4/3 x plus, or y equals negative 4/3 x plus 4/3. Is that what you got? Something like that? I think I see you shaking your head yes. Well, good job. Nice. Now you just look weird. Stop it. Okay. All right. I think we're good, but I'm just gonna whip through this last example. This last example is actually what we'll be doing a lot of. And most of the time we apply this concept is when we're dealing with linear equations. So linear equations we'll talk about later, but those just have x's and y's in them. Okay. So, and most of the time you're going to solve for y in linear equations, and we'll explain that a little bit later, but here's what the equation looks like. 4y plus 6x minus 4 equals 2. Okay, so we're going to solve for y. So there's no cleanup on the left side, no cleanup on the right side. So step 2 is, are there y's on both sides? Nope. So step 3, get rid of everything else except the y terms. So get rid of the constant and the other variable terms. So I'm going to bring all this over here. Let's try the shortcut. So 4y equals, let's see, a negative 6x over here, and then a positive 4 over here. Well, there's already a 2 over there. So a positive 4 and a 2 become a positive 6. All right, last step, divide by 4. So y equals negative 6x over 4 plus 6 over 4. And I can reduce this. Negative 6x, that's just, what is that, 3 halves? So you can just say negative 3 halves x plus 3 halves. That's it. Okay, so you'll be doing a lot of this kind of stuff in a little bit. So get some practice with that. And yeah, so your homework this week is just 39, 40, and 42. So this is lesson 42, but problem set 42 will have problems from 51 as well, or 41 as well. So you'll get practice there too. All right. Any questions before I sign off?
Any?
Good. All right. I think these problem set problems will give you some practice, but if you're still having issues, let me know and we can go through some together. All right. Good job, guys. We'll see you next week. Don't forget to do that practice test by Tuesday to get 10 points extra credit. Okay. All right. Well, I'll see you later.
Flack math. Give me some math and I'll give you some flack. Flack math.